Alright, these are the notes on absolute value. And this is something that you've probably learned before, so hopefully this will just be a recap. So absolute value, alright, focus it there. Absolute value is defined as the distance that a number is from 0. So it's a distance that the number is from 0. Okay? The symbol for absolute value is these two bars. These two bars. And these two bars actually mean what is the absolute value of. That's the absolute value of whatever is in the bars. Now, absolute value is a distance. So if you think about distances when you travel, if you're going to the beach and you travel, say you travel 100 miles to the beach, when you come back from the beach to home and you travel the same 100 miles but you're going in a different direction, it's not negative. So it's still a positive 100 miles even though I'm going the other way. So distance is something that is always going to be positive. So absolute value is always positive. You can't have a negative distance. So it's always positive. So let's look at some examples. So determine how to find the absolute value of negative 12 on the number line. So the first thing I'm going to do is I need a distance to 0. So I'm going to start at negative 12, and then I have to get all the way to 0. Okay, I get all the way to 0. Now I want to know how many spaces that is. How far did I move? So I'm going to count my spaces. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 spaces. So the distance between negative 12 and 0 is 12 spaces. So negative 12 is 12 spaces away from 0, which means that the absolute value of negative 12 is 12. And when you see this, you should think it's like solving. It's like solving. So I would cross this out because I'm going to solve it and it becomes 12. Let's look at the next one. Same idea here, just a different number. This is 7. So demonstrate the absolute value of 7. So I'm going to start at 7 again. And I'm going to go all the way to 0. I'm counting my spaces. 1, 2, 3, 4, 5, 6, 7. 7 spaces. So the number 7 is 7 spaces away from 0. So the absolute value of 7 is 7. That's how far away it is. That's the absolute value, the distance from 0. Let's flip onto the back. Okay. Example 3. Circle each statement that is true. Okay, so I'm looking for things that are true here, correct. First thing I need to do on each of these is to solve the absolute value. So I literally need to solve it. I'm going to solve this absolute value. I cross it out and put the number above it. 5 equals 5. Well, that's true. Next one, I have to solve the absolute value. So it does not matter which side of the equal sign I find the absolute value bars. That's where I'm going to cross out the number and put the positive above. 15 does equal 15. Now, what about the absolute values on both sides? So let's solve them. Absolute value of negative 3.4 is simply 3.4. And the absolute value of positive 3.4 is also 3.4. Those two are equal. The next one, I've got an absolute value here, so the absolute value of 10 is 10. Negative 10 is not equal to 10. This one is false. The next one over here, the absolute value of negative 3 2/3 is 3 2/3, which is equal to 3 2/3. So it can be a fraction. It can be a decimal. It doesn't matter here. So now I'm going to take the absolute value of negative 8. Take my absolute value here, it would be 8. 8 does not equal negative 8, so this one is also false. Now, another way to think of these absolute value bars is I kind of think of being in jail, right? Those are the bars of jail. And when somebody goes to jail, we'd like to think that they're rehabilitated to become a better person, to come out and do good and do the right thing. So when you go out of here, out of jail, you should be more positive. So everything that goes into jail is going to come out positive. However, if you don't go into jail, you're going to continue doing the wrong thing and be negative. So what happens when the negative is outside of the absolute value symbol? So if I look at this one, I see the negative absolute value of 15, which is different than the absolute value of negative 15. Okay, do we see how those are different? In this one, the negative sign is outside the absolute value. So the 15 inside the absolute value changes just to 15, but the negative doesn't go away. It stays negative 15 because that negative didn't go inside the jail bars. I'm not taking the absolute value of that negative, so I can't change it to positive. Okay, so it's outside the jail bars, it didn't go to jail, and it's still negative. However, this one, the negative is inside the absolute value bars, so it does become positive. Similarly, if I have this is the negative absolute value of negative 15. So I would take the absolute value of negative 15, which I know is 15, and the negative sticks around because it's outside of the bars. So you only take the absolute value of the number inside the absolute value bars. Okay? If it's outside, it's not becoming positive. That's the only thing that's really a trick here, something you need to remember. So let's look at the U-try. What is the absolute value of negative 2.5? Well, that just means I would be putting my bars there. So the absolute value of negative 2.5, I know, is 2.5. Absolute value of negative 19 twentieths, 19 twentieths. Circle two numbers that have the same absolute value. So that's meaning that if all of these, I'm taking the absolute value of each of these numbers. So the absolute value of negative 8 is 8, the absolute value of 5 is 5, the absolute value of negative 4 is 4, the absolute value of 8 is 8, the absolute value of 0 is 0, and the absolute value of negative 1 is 1. So now I can look and see, oh, the absolute value of negative 8 and the absolute value of 8 are both equal to 8. Those are two numbers that have the same absolute value, which means they have the same distance from 0. Let's do some comparing. So the first thing we're going to compare here is I need to solve the absolute value. Then I can compare the two numbers. So here the absolute value of negative 2 is 2. 6 is greater than 2, so I would put the greater than sign. Remember, this points to the smaller number. The next one, the absolute value of negative 8, that's 8. Negative 7 is smaller than 8, so I would put less than, pointing to the negative 7. The absolute value of negative 9 is 9. 9 is bigger than 5, so I would have the greater than symbol. And finally, the absolute value of negative 2 is 2. 2 is equal to 2. They're the same number. Last one. Demonstrate the absolute value of negative 5 on the number line. Then demonstrate the absolute value of 5 on the number line. Okay, so if I look here, I've got negative 5. The absolute value of negative 5 is 5. And the absolute value of 5 is also 5. So that's what I'm going to prove. So I'm going to put my 0 right in the middle of my number line and then number it. 5 to the positive, 5 to the negative. Alright, so if I start at my negative 5 here, then I'm going to go to 0. That's 1, 2, 3, 4, 5 spaces. Similarly, if I start at 5, and go to 0, 1, 2, 3, 4, 5. That's also 5 spaces. So when I explain, the absolute value of negative 5 and the absolute value of 5 are equal because both numbers are the same distance from 0. Both numbers are the same distance from 0. They're the same number of spaces away, and thus they have the same absolute value. So these are the notes on absolute value. Please watch them again if you need to.